Today we're going to learn about perpendicular and angle bisectors of a triangle. So I'll go through the lesson, and as always, don't forget to come back and write your essential question and your summary. Let's start with some terminology. A segment, ray, line, or plane that is perpendicular to a segment at its midpoint is the perpendicular bisector. A point is equidistant from two objects if it is the same distance from the objects. And finally, the distance from a point to a line is defined as the length of the perpendicular segment from the point to the line. So that may be a little confusing, but we'll see how this plays out here in just a minute. So just stick with us here. Okay, so of course now we're going to start with some theorems. If a point is on the perpendicular bisector of a segment, all right, here's our perpendicular bisector, here's the point that's on there, then it is equidistant from the endpoints. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what that tells us is if CP is the perpendicular bisector of AB, then CA equals CB. All right, C is on the perpendicular bisector, so it is equidistant from the endpoints, which are A and B. All right, and of course we have the converse, which says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if AD equals BD, then D is on the perpendicular bisector of AB. All right, let's see if we've got some examples or more. I think we have another theorem coming up actually. Yes, if a point is on the perpendicular bisector of an angle, then it is equidistant from the two sides of the angle. So if this point D here, okay, let's just read this right here. If AD bisects BAC, so here we are, AD is bisecting the large angle BAC, and DB is perpendicular to AB, right here, see DB perpendicular to AB, and DC is perpendicular to AC, then I know that DB equals BC. Okay, and that goes back to equidistant. We know that BD is the same length as DC because D is on the angle bisector and DB is perpendicular to AB and DC is perpendicular to AC. So for us to know that BD and DC are congruent or have the same measure, we got to know that they're perpendicular to those two sides of that angle. All right, and then of course we have the converse that says if a point in the interior of an angle is equidistant from the sides of the angle, so this point here we're talking about D, if it is on the interior and it's equidistant, and you see I can see that it's equidistant here, these two are both equidistant from the sides of an angle, then I know the point is on the angle bisector. In other words, if DB is perpendicular to AB, which we see right here, DC is perpendicular to AC, which we see right here, and DB equals BC, well, they're congruent, so we know their measures are equal, then I know that AD bisects that angle BAC. All right, let's look at some examples now. In the diagram shown, BE is the perpendicular bisector. This is BE right here. BE is the perpendicular bisector of AC. what segments must be equal? What segment lengths are equal? Well, I know that AB equals CB, right? AB equals CB. And I would have to know that AE equals CE, right? Okay, now they're telling us that AP is congruent to CP. AP is congruent to CP. What can we conclude about P then? Well, based on what we just learned in those theorems, I can conclude that P is on BE, which is the perpendicular bisector of AC. That's what I can conclude because of the theorems I just learned. All right, here's another example. Solve for x. Well, let's see. We know CF is an angle bisector because these two angles are marked as congruent. We know that FB is congruent to one side of the angle and FD is, not congruent, I'm sorry, perpendicular. FB is perpendicular to CB and FD is perpendicular to CD. Therefore, we know that they're equidistant, right? F is equidistant from one side of the both sides of the angle. So what I know is that these two are congruent, so I can solve for x by setting them equal. All right, so 2x equals 6, therefore x has to be 3. And that's all there is to it. All right, I think we may have some more examples. Let's see here. Yeah, one of its angle bisectors. All right, find x. The measure of angle 2 is 4x plus 5, and the measure of angle 1 is 5x minus 2. Well, that's an angle bisector, right? XP is an angle bisector, so all I do is set these equal to each other. 4x plus 5 equals 5x minus 2. So if I subtract the 4x and add the 2, I'm going to end up with x equals 7 there. That was an easy one. And let's see, find x. The measure of angle 2 is 1 plus 28x, and the measure of angle XVW. So the whole thing is 59x minus 1. All right, so let's see what we're going to do here. Okay, we know we've got an angle bisector, so we know that the measure of angle 1 and the measure of angle 2 are the same. So what I'm going to do is I'm going to say 2 times the measure of angle 2, which is 1 plus 28x, equals the measure of angle XVW, which is 59x minus 1. So that's going to give me 2 plus 56x equals 59x minus 1. Therefore, negative 3x will be negative 3. Therefore, x equals 1. Okay, we got a little proof here. Why don't you see if you can take a stab at this proof before I do it? All right, why don't you pause right here and come back and let's talk about it. Alrighty, so what we're doing here is we're actually proving the angle bisector theorem, which of course means we can't use the angle bisector theorem in our proof. So we've got to go back, and it looks like to me we're probably going to have to prove that those two triangles are congruent. So if you didn't start down that path, go ahead and pause again and take another stab at it. Here we go. Of course, I listed my given statements first. And then statement number 2, I'm going to say that angle PQS right here is congruent to angle RQS. And how do I know that? Because they told me that QS bisects angle PQR. So whenever they give you a bisector, your next logical step is going to be that the two things that are created by the bisection are congruent. So I've got that. Okay, let's see what else they told me. That They gave me that this is perpendicular to this and this is perpendicular to this, so I'm going to go ahead and say those two angles are right angles. SPR and SRQ are right angles, and that's because of the definition of perpendicular lines. Okay, now that I know that, I'm just going to go right ahead and say that those two angles are congruent, because remember what I'm getting at is proving those two triangles are congruent. So the two angles are congruent by the right angles theorem. So now I've got it. I've got two angles, and all I need is a side, so I can say that QS is congruent to itself, which I did in step 5. And now I can say the two triangles are congruent, SPQ and SRQ, by side angle side, angle side, angle side. All right, so I've got my two triangles. Now what I want to do is say that this side is congruent to this side because they're corresponding parts of congruent triangles, CP, CTC. And then finally, I can say that the two lengths are equal because of the definition of congruent segments. All right, so there's your lesson. Next time we will look at bisectors in triangles. This was a lesson on bisectors, but we'll learn what happens when these bisectors intersect one another. Lots of good stuff to come. Don't forget your essential question and summary.